We're in the other part of the business, the aerospace side, and I'll talk a little bit more about how technology and innovation is bringing product, services, and facilities together. When we decided to really expand globally, we looked into this part of the world, and Singapore is our second home. In Seletar, which is the north of this island near Woodlands, we have a 65,000 square meter facility. There's two factories there. One does the high-value manufacturing of the fan blades. So when you look at a gas turbine engine, and at the front you see the sort of the titanium fan blades, that's made here in Singapore. It's very hard to do. The only other factory that makes those fan blades is in the UK. About 200 meters from that facility is another factory where we assemble and test gas turbine engines. 3 different types of engines are assembled, 18,000 parts and components coming in, and 1 engine leaving the building. And the only other factory that makes and assembles the large civil engines is in the UK. So because of those significant activities, it is our second home, and the region and the opportunities with the region in terms of supply chain collaboration is what we're looking at in serving our customers. So we don't make cars, but we do these 3 business units. Civil aerospace, we supply the engines to 35 commercial aircrafts, different types. Right now, there's 400,000 people up in the air that are powered by Rolls-Royce, right now. So there's a huge amount of design and engineering to allow that to happen. We serve defense customers as well for performance and aircrafts. And then there's also another part of the business called the power systems. Diesel, high-speed reciprocating engines. We take about 20,000 on an annual basis into the market, and backup power stations, for example, stock exchange in Singapore is MTU engines. So these are fairly large land-based type engines. But that's not what I want to talk much about. What I do want to focus more about, what is changing. And it's really encouraging to be invited by the built environment to understand what's actually changing in the sort of the conversations we're having with our customers and the kind of facilities that we're going to start adopting into the future. CO2 is a key agenda. Sustainability is a key agenda. And if I look at the sort of the emissions per CO2 across the different sectors, you'll have seen this many times. Power generation and manufacturing constructions are the biggies. And then you've got the others, road transport and so on. Air transport is about 2%. We still have a fantastic opportunity to make this much, much more sustainable for our future. And if you look at the kind of CO2 emissions in the products that we've taken out, so if I look at the datum of a Trent 700 engine, which came out into service around sort of mid-1990s, every single engine we brought out since then has been a reduction in CO2. We spent £1.4 billion on R&D. 2/3 of that investment of that £1.4 billion every year goes into environmental factors. We try and do 3 things: reduce emissions, reduce noise, reduce fuel. Doing one of them is actually really easy. Doing all 3 of them together is really hard. And we've managed that trajectory with incremental innovation. And today we've got the Trent XWB on an A350 engine. It is the world's most efficient engine we have today. And yet we're investing into the future. The Advanced 3 and the Ultra Fan will be a 25% reduction in CO2 from a datum of Trent 700. Our target is not to stop there and to really hit minus 30% of CO2. Some of the kind of technologies that you'll see in the engines that are not out today, but we're building, we're developing, we're testing. I'm not going to go through the technologies that we deploy, but some things to note is materials are changing. We're moving away from the sort of the titanium into more carbon composites and carbon sort of fan blades. We've got high power density gearboxes that sit behind the fan to basically slow the front end down, make the back end even faster. That's how you improve the efficiencies and so on. 10% more efficient than today's most efficient engine. And we'll take this out to the market by 2025. Another thing that you'll have probably heard about is the whole electrification story. And you'll have seen many startups that are coming into the sort of the world of electric flights. And they've got the sort of full electric architecture from batteries to energy storage. We've got a slightly different version of that. We're investing significantly in eVTOL, electrical vertical takeoff and land. It's a hybrid solution. So you're not limited by distance. You still have a traditional gas turbine engine, but you have a very intelligent electrical propulsion architecture that sits around that. And now you're talking disruptive innovation. Because that incremental trend that you saw earlier on, that is not what we're seeking for anymore. We're seeking for a huge step change in the amount of fuel consumption, reduced fuel consumption, and reduced emissions. But the real sweet spot is the regional jets. And this is much more distributed electric propulsions on the wings. You still have a gas turbine engine, but you can now build airports in cities because your takeoff is 1/3 of the size that it is today. Your emissions are significantly reduced, and there's virtually fantastically reduction in noise as well. So you can start building airports in cities, and you can imagine, especially in our geography of Southeast Asia, that's a huge value proposition. And then as we go further on into the right of the timescale, by 2040, we'll see more electrification coming into the wide bodies. And then there's the digital revolution that's impacting all our businesses in our areas. And when we look at digital, what we're doing is connecting. So one engine on one side is actually connected to the other engine. They're collaborating. They're actually deciding what the power sharing should be. What is the most optimal power share? I'll reduce my trust by this certain percent. Why don't you increase it by so much? And then there's contextual collaboration. So really sensing the environmental data and what's happening around the surroundings and making some really informed decisions. And we're putting that intelligent architecture around our frameworks of the intelligent engine. The other areas that we're doing is collaboration with not just a Rolls-Royce solution, but really bringing the whole value chain of the aerospace activities together. We've got loads of context data, historical data that we're using to make decisions. Wrap that with manufacturing data and maintenance data. We have to look after our engines for a life cycle of 20 to 25 years. We've been collecting data for 25 years now on every single engine. From today, looking backwards, 25 years worth of data, and so